All right, so we've already started this one. I had to stop the tape because we needed to reorient. So here we have NPR. Here we have f of x equals 0.25 to the x minus 1 plus 3. All right, so we need to rewrite this so we have a fraction base. It's a lot easier to deal with, so 0.25 is 1/4. And I've already plugged in the values because I did that when I was recording and it needed to be oriented. So here we have, we've raised 1/4 -2 to the second power. We're going to leave off the first value because -216 doesn't fit on the graph. -1/4 does. Yay. And so does, we have 0, 1, and 1 1/4, and 2 1/16. Is this one in the notes? No. All right, so here's our base graph. How far are we going to translate it to graph this one? Purple 1. 3 units, what direction? And what else? Yep. All right, so -1 on the x translates that 1 unit to the right, +3 to the whole function translates that 3 up. What's the horizontal asymptote going to be? Orange 3. For this function here. 3. All right, so y equals 3. It's going to be an equation. Let's graph the horizontal asymptote. And then we're just going to shift our function up, shift our function 1 to the right and 3 up. So, oops, 1 and 3. Here we go, 1 over and 3 up. 1 to the right, 3 up. 1 to the right, 1, 2, 3 up. All right, so here's our function. All right, you can see why we had to leave 16 off. Shifting a 3 up makes it even worse. The domain, anybody at the purple table? And the range, yellow 5. What would the range be? I think this is what he said. 3 to infinity, right? So function's been shifted up 3, so it's not going to go below 3. Any questions on this one? People watching the tape, if you have questions, you'll have to ask me in class. All right, so here's the next one. All right, so our function that we're graphing is f of x equals -5 times 0.6 to the 2x plus 4 power minus 2. The base graph is f of x equals -5 times 0.6, the 2x power. What would 0.6 be as a fraction? Not 2/3, that's 0.67. 3/5, 3/5. So f of x equals -5 times 3/5. All right, because this is 6/10, right? That's its name, and that's the same as 3/5. All right, so the 2x power. So I'll try -2, -1, 0, 1, and 2, and we'll see what happens. All right, so -5 times 3/5 to the 2 times -2 power. That's going to be the reciprocal because of the negative exponent. So that's going to be -5 times 5/3 to the 4th power, which is -5 times 5/3 to the 4th power is 625/81. So that's going to be 31/25/81. I think we can agree that that's not going to fit on this graph. This one in the notes? Yes. Okay, we're leaving that one off. All right, so -5 times 3/5 to, and you can, if you just want to write the value or write a little bit of this, you can. -5 times 3/5 to the 2 times -1 power is going to be -5 times the reciprocal 5/3 squared. So that's going to be -5 times 25/9, which would be -125/9. It'll be a stretch, but we'll fit that one in. So we have to fit in a negative. Negative 5 times 3/5 to the 0 power is negative 5. If I remember correctly, this one grows really slowly, so I'm going to add a 3 in there. Negative 5 times, or decays really slowly. Negative 5 times 3/5 to the first power is going to be, well, those will cancel out. It's going to be negative 3. Negative 5 times 3/5 squared would be negative 5 times 9/25. So the 5s will cancel here. So that's going to be negative 9/5. We're still above 1. Negative 5 times 3/5 cubed is negative 5 times 27 125. So the 5s will cancel. That'll be 25. We're still above 1. Negative 27 25. We'll get one last one in here. Somehow I fit 4 in here when I did this with second period.
What's the value for negative 1?
For negative 1, it is negative 125/9. All right, so one last value here, and that is going to be 4. Maybe I had this pushed down a little bit, and that's how I fit it in. All right, so 4 would be negative 5 times 3/5 to the 4th power, which would be negative 5 times 81 625. And the 5s will reduce. That's going to be negative 81 125, and we're finally smaller than 1. Took a little while. I'm going to move everything over a little bit because I'm not going to need this much. I'm not going to need anything up here anyway. Domain, range, horizontal asymptote. Move this over. All right. So first of all, let's graph the base graph. So we have negative 1, 125/8, if I remember correctly, is about 13.8. So 11, 12, 13. So we'll just put it right here. That's the best we can do. All right, and then 0, negative 5, 1, negative 3. It's a real slow decay here. 2, negative 9/5 is almost negative 2. It's just 1/5 shy. Negative 27/5, a little bit more than 1. And then 81 125 is a little, about 3/4. So here's our graph. And of course, we're down below here, and I have to be translating it down. How far does our graph translate? Green 5. What would the horizontal asymptote be? Purple 2.
Horizontal asymptote would be negative 2.
Yep, y equals negative 2. So we'll graph that in. All right, and so we're just going to shift all of our points. All right, so it's going to go 2 down and 4 to the left. Here's one of our points. 1, 2, 3, 4, and 2 down, and it's going to make it about here. And then this one's about here. 1, 2, 1, 2. Oops, excuse me. 1, 2, 3, 4, 1, 2. Over here. Did I shift him far enough? No, oops. Did I shift him? Oh, I only shifted him. Wait. 1, 2. Oops. He only went 3. This one only went 3, huh? He's supposed to be over here. Wait. Let me recount this. All right. 1, 2. I missed somebody. 1, 2, 3, 4, and then 1, 2. 1, 2, 3, 4, and 1. I missed him again, but I know who I missed. 1, 2, right over here. I missed this guy over here. Wait. There we go. And then 1, 2, 3, 4, 1, 2. Did I miss anybody else? Oh, I missed him. 1, 2, 3, 4, 1, 2. Now we got everybody. And we can't move him because I have nowhere to go. So here's our graph. Did not seem to have as much difficulty counting the last time I did this. All right, there's our graph. All right, let's do domain and range. Blue 3, domain. And the range, green 3.
Negative infinity to negative 2.
And that's the last of our graphing. So domain was negative infinity to negative infinity, range negative infinity and negative 2. We're reflected and we're shifted down. All right, so if you have questions on these, ask in class. Thanks for watching the podcast.